Well, now moving to the next question. In the above problem, that means the same problem. If the lift moves upwards with a constant velocity, yes, here we go. The same problem was given, children, in which a spring balance is there and a mass of 2 kg is being given. Spring balance, mass of 2 kg. Okay, so reaction force R, weight mg, but now the lift is moving upwards. Upwards means accelerating upwards. So in this case, the equation is written as R minus mg equals to ma. R is equals to m into g plus a. Therefore, substituting the values, what is the mass given, children? Mass of the body is given as 2 kg. So 2 into the value of g, let us take it as plus constant velocity of 2 meters per second. So whenever the lift moves with constant velocity, so constant velocity means acceleration is 0. I told you, because the value of acceleration is v minus u by t. So uniform velocity or constant velocity indicates v is equals to u. So when v is equals to u, the acceleration will be 0. So 2 into 10 plus 0. Okay. Hence, the value of R is found to be 20 newtons. What is that, children? 20 newton. But here in options, it was given as kgs. I already told you, kg force is nothing but G. Kg force is nothing but G. So for this, let me rate it as, I don't want to confuse you. Mass is nothing but how much? 2 kg. G, I'll keep it here. This is 0. Hence, you got the answer as 2G. Now it will be clear. What is the answer, children? 2G. Okay. So, we know the value of kg force as G. Okay. So, this can be written as 2 kgs. Clear? If 1 kg force is G, then it will be 2 kg into G. This is nothing but 2 kg. Hence, option is option number A, that is 2 kg. I have just taken G. Next, 10th one. If the lift in problem moves up with an acceleration equal to acceleration due to gravity. Again, the same problem is continued, ma. So, the same lift was given. Okay, and this lift is moving upwards with some acceleration, and this acceleration now is given as acceleration due to gravity. The same spring balance to which a body of mass 2 kg is being connected, and given that its weight is acting downwards, normal reaction force is acting upwards. But in the question, it is given that moves up with velocity. Whenever the body moves up with velocity, we found the equation R minus mg equals to ma, or R is equals to m into g plus a. So, mass is 2 kg. Gravity is G, A was also given as G, then R is equals to 2 into 2G, or R is equals to 4G. What is that? 4G is measured in newtons or kg force. If you want to measure in kg, you have to divide this. So, you have to separate this. This can be written as 4 into G kg. Is that okay, children? So, what is that value? So, G itself is taken. Answer is 4 kg. R is equals to 4G. So, mass, Now it is clear. So weight is 4g means mass is 4g by g, that is 4 kg. Okay. Weight W equals to 4g. mg equals to 4g. m equals to 4. That's it. So answer is 4 kg. Similarly, you can apply for the previous problem also. mg equals to 2g. So gg cancel, m is equals to 2 kg. Okay, like this you can understand. Well, 11th question. A man is standing on a weighing machine placed in a lift. Lift is there, weighing machine is there. When stationary, when the lift is at rest, his weight is recorded as 40 kg. So whenever the lift is at rest condition, we know the formula R is equals to simply mg, and this value was given as 40 kg. At this condition, mass is given as 40 kg. If the lift is accelerated upwards with an acceleration of 2 meter per second square. So when the case 2, when the lift is moving upwards, then formula will be R equals to m into g plus A. A value was given as 2 meter per second square. Then the weight recorded in the machine will be, simply find out the value. So mass given as 40 kg, value of g 10, acceleration 2. So R is equals to 40 into 12, R is equals to 480 newtons, or R equals to mass equals to, divided the value with g, this is 48 kg. So what is the answer, children? 48 kg. Moving to the next question, children. 12th one. An elevator weighing 6000 kg. Mass of the elevator is given as 6000 kg, pulled upwards by a cable. So let us imagine this. Elevator means again lift, whose weight, the weight of the elevator is 6000, is now pulled up with a cable. That's it. Okay. Some tension must be acting in the cable, and this is pulled up means accelerating upwards, whose value is given as 5 meter per second square. Taking g to be 10 meter per second square, the tension in the cable is, so clearly the weight of the elevator must be acting downwards and the tension must be acting upwards. As it is an upward motion, we can write the equation of motion as T minus mg equals to ma, or T is equals to m into g plus a. So what is the mass, children? Mass itself is given as it is, the cable is pulling 6000 kg mass. So 6000 into g, you are asked to take it as 10 meter per second square, and acceleration was given as 5 meter per second square. Hence, the value will be 6000 into 15. Okay. So, what is the value of 6000 into 15, children? 90. So 90,000 Newton. Hence option D must be true. Okay. So well, moving to the next question, 13. The ratio of the weight of a man in a stationary lift and when it is moving downwards with uniform acceleration A is 3:2. Let us try to solve this. So case 1, what it was given? The man in a stationary lift. So stationary lift, or the lift is in rest condition. Stationary means rest condition. Whenever the lift is in rest condition, we can say that the weight of the man W1 is simply equals to mg. But case 2, if you observe, when it is moving downward with uniform acceleration. Downward motion means force is given by m into g minus a. Downward motion is m into g minus a. Okay. So, it was given that. But what is the condition given, children? The given that the ratio of the rest condition to that of the moving downwards is given by 3 by 2. So, substituting all the values, instead of W1, I can replace it with mg. W2, replace it with m into g minus a is equals to 3 by 2. So, solving here, m and m gets cancelled. Cross multiply, you have 2g is equals to 3 times of g minus a, or 2g is equals to 3g minus 3a, or bring the 3a other side and 2g here. This will be 3g minus 2g. Okay. Therefore, the value of 3a is equals to 3 minus 2 is 1. So, 1g, or a is found to be g by 3. Hence, the correct option is option B, that is g by 3. So, moving to the 14th question, a 60 kg man stands on a spring scale in the lift. So, here we have a lift in which a man is standing. Okay. At some instant, he finds the scale reading has changed from 60 kg to 50 kg. Actual mass of the man was 60 kg. But it was given that because of some changes, the mass of the man was changed from 60 to 50 kg. That means his mass is reduced. Okay. Children, so whenever a lift was moving upwards, okay, there must be increase in the mass, no decrease, because m into g plus a. Okay, maybe the lift was constant motion, upward motion is not possible, because in that case the mass may increase. Okay, hence this is not true. The lift was in constant motion downwards. Yes, possibility is there. Okay, the lift was in constant motion in downward motion. Okay, when if it is moving downward motion means what happened? The mass has changed from 60 to 50 kg. So, it can happen. But it was given that then comes back to the original mark. So, whenever the lift is moving downwards, apparent weight may decrease. So, that possibility is there. Then, but why does it again come back to the original reading? It can't come. Once decrease and again coming to the original reading can be possible only when something is happened suddenly. So, sudden force is being applied. Okay. So, the correct constant motion downwards, decrease in mass can happen, but again it cannot regain back the same mass. So, there is a slight differences in that. The lift while in constant motion upwards is stopped suddenly. Yes, stopped suddenly. Some sudden variations are there, means there is a possibility. But I just told you that whenever it is in upward motion, the weight may increase, apparent weight may increase but does not decrease. So, this is also wrong. Now the last one, the lift while in constant motion downwards is suddenly stopped. Yes. So there is a possibility of this. So what happens while there is a constant motion, downward motion means there can be decreasing in its apparent weight. But when suddenly stops means then sudden force is applied on that, and again it may regain back due to inertia. Okay. So suddenly stopped and moving in the downward direction. So, option must be option number D, correct option. Well, 15th one, a bird is sitting in a large closed cage which is placed on a spring balance. Okay, so we have to imagine a cage in which a bird is been sitting. So, here is your bird, children. Yes. It records a weight placed on a spring balance. It records a weight of 25 newtons. So, what was the weight observed? The weight of the bird was found to be 25 newtons. The mass of the bird was given as 0.5 kg. Flies upwards in the cage with an acceleration of 2 meters per second square. Mass is given. and acceleration is given. So some sort of force is being acting. What is the force, children? Mass into acceleration. Mass of the bird is 0.5 and acceleration is 2. So this will be 1 Newton. Okay. So the actual weight of the bird was 25 Newton and the force, because of the movement of the bird as it flatters its wings, so it will be, in order to fly, it applies certain force, the additional force on the spring balance. And how much additional force is applied by the bird? That is 1 Newton. Okay. So now the resultant force or resultant weight acting on the spring balance is actual weight of the bird 25 newtons and the applied weight of the bird, that is 1 Newton now. Okay, the spring balance will now record a weight of. So now the new weight, apparent weight, will be actual weight of the bird plus the force applied by the bird on spring balance. Force on spring balance. So W dash can be written as 25 plus 1, that is equals to 26 newtons. Hence the correct option is option C. So now the last question, children. So a bird is sitting in a wire cage hanging from the spring balance. So what is there, children? A bird is sitting on a wire cage. Again, let us imagine the wire cage. Yes. So here again a bird is there. Hanging in the spring balance. Let the reading of the spring balance be W1. So initial reading of the spring balance, what was given, children? W1. If the bird flies about inside the case, the reading of the spring balance is W2. So now what happens? The bird has flown away. Okay. Which of the following is true? So earlier only bird with case is there. Okay, bird is sitting on a wire case hanging from the spring balance. So W1. Okay, the reading on the, now the reading of the spring balance is W1 whenever simply the bird is on the case. If the bird flies about inside the case, that means the mass of the bird is not there, only the mass of the case is acting on the spring balance. The reading of the spring balance is W2. Okay. Cage with the bird is W1. Cage along with the bird mass is taken as W1. Now, when the bird has only cage is W2. Because the bird is flying inside the case, so its force, its weight is not acting on it. You are asked to find out which one of the following is true. Obviously, here case plus bird is W1, only case is W2. So clearly we have, from this we can conclude that W1 is greater than W2. Hence option B is correct. So with this, let us conclude the chapter, that is Newton's laws of motion. So meet you in the next session. Until then, keep practicing, children. Take care. Thank you.